Hey guys, welcome to Algos Explained. I'm David Kim, and today we have another whiteboarding video for you. Today, it's going to be a really short problem, really easy. So hopefully, I'm blocking the solution for you, so that after you read the question, maybe you can do it on your own. And if you get it, come back and check your answer with me. Or if you don't get it, then I guess watch the rest of my video, and then hopefully I'll help you understand it. This question I took it straight off from HackerRank. They don't sponsor this video, unfortunately, but it is a great resource. And since I'm taking their problem, I thought I'd give them a little plug. And so, okay, so today's question is going to be, you have a diagonal matrix of n of n, and pretty much what you're looking for is you're going to give the sum, the absolute difference of sums of diagonals. And what I mean by diagonals, first of all, is this is a matrix. And so you might ask, okay, what does a matrix look like? If you're given a problem like this, hopefully you already know what a matrix looks like. But in case you don't, well, here it is. A matrix is pretty much an array of arrays that are going to, well, depending on if it's n of n, it'll be a perfect square. If it's like n of m, then whoever's giving you the question, they're assuming you understand that it doesn't have to be a perfect square. So it could be a rectangle. In our situation, it's a perfect square. And again, that is how you know. If it was n of m, then you have to watch out. This isn't always going to be a square. But if it's n of n, or n, then you know it's going to be an even square. And that does make a huge difference, especially for our problem. So this is how it looks. This is kind of similar to like when you're doing like board games or whatnot. You're going to have arrays of arrays, like especially for the simplest game, tic-tac-toe. If you program that, you're going to probably be working with arrays of arrays in order to kind of make your places for your x's and o's. So let's just go through a simple example. This is an array, and so this is a 2D array. We're going to have some numbers here, and we're going to work with just some simple numbers. 4, 5, 6, 7, 8, and 9. And what I mean by this being a 2D array is that this outer array has his members being arrays, and within those arrays, they're the actual number values. And so that's what it means to be a 2D array. You have an array inside of an array. If you have 3D arrays, it would be an array of arrays, which within those arrays would be more arrays. And you can go deep, like 4 or 5, whatever you want to do. And for our question, excuse me, what we want is the absolute difference of the sums of diagonals. So for one thing, you know that these are always going to be numbers, not necessarily positive or negative. They can be either one. And with that, it wouldn't really matter because the first step we're going to be doing is we're going to be summing the diagonals, and then we're going to be finding the absolute difference. And we'll go through that in a second here. But just to take a higher look at what our problem is actually doing, pretty much what we're going to eventually do is take this 1, 5, and 9. So that's going to be one diagonal way, and the 7, 5, and 3, that's going to be another diagonal way. And so diagonal 1, let's call it D1. I'm going to step over here for a second. D1, pretty much if we consider this to be our D1, that's going to be 15. And D2 happens to also be 15. It'll be this way, 7, 3, 5. And so that's like step 1 of the problem. And what they want us to do is they want us to find the absolute difference. Pretty much we just have to subtract those guys. And in case it's a negative number, do the absolute value of that subtraction. So the question itself, pretty simple. Again, you shouldn't be tripped up by the fact that this might be bigger or smaller, because you will know that it will always be a square. If it was like a rectangle, then yeah, it becomes an issue, because say you had a 4x3, then where's that perfect diagonal? There wouldn't be. And so it would probably be impossible. Maybe if they didn't specify n of n, maybe that would be like an error check for you to do. But they do specify it's going to be a perfect square. It's going to be numbers. It's not going to be some random value. So you're guaranteed that much. And so all you need to do is, once you have the game plan, you know, okay, I need to find the sum of the diagonal first. And it's like a 2-step process. Find the sum and then find the difference. And so let's go ahead and look at our code. And that is pretty much exactly what we do here. We have a matrix, and we already know that this is an array of arrays. And so we know that it's going to be a 2D array. So some numbers that we do need to keep hold of is the first sum. sum 1 being like D1 here for the sum of the diagonal 1, D2, we just call it sum 2 here. And it can both be zeros, it doesn't matter, because whether or not they're positive or negative, we'll just be adding to those. Some questions, they don't allow you to start with 0 simply because you shouldn't. But I think that's off topic. We don't need to talk about that. In our case, it does work. We're okay with starting off at 0, so we'll just start off at 0. This length here, I just thought it would be a good idea to kind of have the matrix length. The reason why I want to hold that number is because, well, I don't want to call matrix.length every time I need that. And you might see in the problem, we will use that a couple more times. And one of the biggest places we do use that is to know how many times we need to go on the diagonals. And once again, because it's a perfect square, we don't have to like tap into the first array and count the length of that. We can just do the length of the whole entire array, because whether or not you find the length of matrix of 0 being the first array, or just find the matrix length, it'll be the same. And so if we go look down here, this is our for loop. We do, like we said, we do need to find the sum of the diagonals. And so how are we going to do that? Well, we need to at least take a look at all these numbers. And you might be thinking, do I need to do 2 for loops, one round to get this diagonal and the second round to get this one? But you don't. They have pretty much, you're not really mutating anything, you're not changing anything, you're just reading numbers line by line or array by array. And so you can all do that in the same for loop. And I do it right over here. See how I have sum 1 and sum 2, they're both being added, whatever value they need to be looking at. And so let's go ahead and take a look at this. Matrix I of I. And so this is kind of the format you have to take when you're dealing with a 2D array, because let's take this example and let's just pretend I is 0 right now. So if we look at matrix of 0, what will that give us? That will be looking, this big thing's the matrix. Matrix of 0 is that first one right there. So if we just like kind of printed out matrix of 0, we would get 1, 2, and 3. And now if we want the 1, well, we want the 1 to start our diagonal this way. That is the index of 0. So what we would have to do is we can maybe you even want to put that as a variable. If you did like row 1 equals matrix of 0, then now you can do row 1 of 0. And now you know that row 1 is equal to this guy right here, so row 1 of 0 will be 1. But another way to do it is to skip this variable step and just do matrix 0 of 0, and that'll give you the 1. If you do matrix 0 of 1, you'll get the 2. If you do matrix of 2, you'll get the 3. We're talking about indexes, not these numbers right now, in terms of what goes right there. And if you had matrix of 1, then you're tapping into now this one, because of the matrix array, we're tapping into the element that's in the first index place, which is here, this guy, the 4, 5, 6. And within the 4, 5, 6, now you're tapping into whatever index you place in here, whether it be 0, 1, or 2, you'll be tapping into 4, 5, and 6. And so that's why we have this format right here. And one thing you do have to watch out for when you start doing these formats is, especially if you start dealing with non-square 2D arrays, there are times where you're going to kind of do like, or even in this question, I mean, it's easy to mix things up sometimes. We know we have lengths of 3, but so that means it's an index 0, 1, and 2. And if we try to tap into like matrix of 3 and something here, well, despite whatever this is, if we ask for this itself right here, if we just ask our problem to give us what this returns, that'll probably be undefined. And you might want to fact check me on that one, but it won't throw an error yet. Once you start doing something like this, where you want like another index of that, well, you can't index into undefined. And so, well, while this might be able to give you undefined, you can't index into undefined, therefore that will throw an error, and your problem won't even run. And so that's just something to watch out, especially once we start dealing with 2D arrays that aren't square. It's really easy to lose track of, like, if it was a rectangle that was long, sometimes you might assume that the length of it also has the height of it and kind of get mixed up there. Once you start messing around with more 2D arrays, you'll remember what I'm saying here, and there's no real solution to it. You just gotta watch out. You gotta make sure your indexes are the same. And when you get an error, something like you can't index, like you can't find an index of 2 of something, you'll know that's what the problem was. You're trying to use this 2D array format, and you can't get like an index 0 of something that's undefined. Cool. And so we were at right here. So we're indexing into matrix I of I. Same thing right here. Like I said earlier, we don't have to have 2 for loops to find this diagonal and this diagonal. We can look at these numbers every time we go here, here, and so while you're here in the for loop on this first index of 0, you can both look at the 1, you can look at the 3 too. And so that's exactly what's going on here. Well, actually, well, that's not exactly what's going on here. While you're here, you're looking at this one actually. But we'll get to that. We'll do a run through of this question using this example. Pretty much the idea right here quickly is that you're using both sums and you're adding to them. This will get us the sum of the diagonals, and at last here we want the absolute value, so we use the math.absolute function right here, and we have sum 1 minus sum 2. It doesn't matter which order those are because they're going to be the absolute value of them, and so whatever it is, it'll be positive, and that's the solution right there. That is not too complicated. Maybe the matrix thing might have tripped you up if you've never worked with the 2D array before, but other than that, I would say not too challenging of a problem. There are harder matrix questions, and if you're interested in those, just practice more with the easy ones, and then you'll get to a point where matrices will come easily to you. Same thing with working with 2D arrays, 3D arrays, or whatnot. And so at this point, I'm going to go through this code using this example. And so if you want to stop here, thanks for watching, and thanks for stopping by. And let's get to it right now. All right, so we are going to use this example 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's going to be our matrix. We know that it's a length of 3. There is 3 by 3. It's a 3 by 3 matrix. We also already know that just by looking at it, we know that this diagonal is 15, this diagonal is also 15. So our answer is going to be 0. And it doesn't matter if any of these numbers are negative, it'll just get solved in the math. But let's walk through our code, see what's happening at each step. This process might be something that the interviewer does ask you to do for them. And so hopefully, if you write your own code, hopefully you can walk through it and explain it out loud as I am doing for you guys right now. So let's go ahead and first look at all of our variables. Looking at length, and length is going to be 3. Again, we're looking at this matrix here. And so we know that when we did matrix.length, we didn't look at this length, we looked at this length, and we knew, okay, 1, 2, 3, that's the length now. And so length is 3. Sum 1 and sum 2, that's at 0 right now. That's at 0, and since we're just going to be adding to it, whether it's positive or negative, doesn't matter. So we can initialize that at 0 safely with confidence. And so now we're at the for loop. The for loop is going to do matrix.length, and we could have just used length there, of course, because we set the variable, and so maybe we should have. But I feel like in terms of using a for loop, I like to know exactly what I'm iterating through. Of course, if this was super long, I guess I would use a variable. So I guess this case by case. But pretty much what we're doing here is we're starting it at 0 and we're incrementing it until it reaches 3 is going to be our last I, because matrix.length is 3. And so it's not going to, or it's going to stop at 2, sorry. Matrix.length is 3, so I is going to be given the values of 0, 1, and 2. It's never going to hit I of 3, which is good because that'll make our problem crash. And so let's go ahead and look at sum 1. What is that looking at? So sum 1 is matrix I of I, and right now I is 0. And so matrix of 0, what is that? That is this first one right here. That is 1, 2, and 3. That looks like a 3 and a 3, sorry. 1, 2, and 3. But we do I of I, so pretty much we're looking at this array of 0. And so what is that going to be? That's going to be 1. Because this index is 0, 1, 2. Those are the indexes. This was the length I was doing here. The indexes are 0, 1, and 2. And so when we tapped into matrix of I, which was 0, we got this first one, then we got 0 of 0, so we got the 1. And so sum just plus equaled 1, and so this becomes 1 right now. And same thing for sum 2. Let's look at what it's doing. We're looking at matrix of length minus 1 minus I. So we're looking at matrix. How about we'll do it under a little lower. We'll do matrix length minus 1, so that's 3 minus 1, that's 2, minus I, which is 0, and of I, so that is 0. And so now we're looking at matrix of 2 pretty much. What is matrix of 2? Matrix of 2 is this one right here, the 7, 8, and 9. And so now look, we're looking at the zeroth index, of this one right here, and that would be 7. That is 7, and so sum got plus equal to 7. And so this kind of, hopefully you're not thrown off by what's going on here. We're using a for loop to kind of iterate through the matrix, yet we're taking advantage of our variable length and what I can bring to us pretty much as this one moves down diagonally. What sum 2 will do is it'll move up diagonally. And so that's the last thing that happens in this for loop. We go back and I is now 1. Actually, I'll just cross this out. I is 1. And so let's look at this matrix I of I. This sum 1 is pretty simple. We know that we're always going to be moving down diagonally. So if we just look at here already, is 0 of 0, 1 of 1, 2 of 2. So we already know I of I, that's always going to be just 1 of 1 or 2 of 2. And so what is 1 of 1? The first index of this matrix array is going to be 4, 5, 6. What is the one index of that? That is the number 5. And so here we get plus equals to whatever that value is. That value is 5, and so this one goes to 6. And matrix 2, a little bit more complicated, not too complicated. We're looking at length, and I'll just write it down here. 4 minus 1, which is 3. I could have, I couldn't have hard-coded that. You never want to do that. And it doesn't matter which order you bring those in. Maybe you wanted to flip that around, but it doesn't matter. I is going to be 1, and so of 1. And so now that is 3, 2, that's matrix 2 of 1. And wait, no, I messed up. I messed up length. I keep thinking length is 4 for some reason. Length is 3. I think it's because when I was solving this question, I was working with a 4x4. But anyways, length is 3, and so 3 minus 1, that's 1 of 1. Same thing as that guy right there. We are at the 5 right now. This guy was going down, this guy was going up. We met at the 5. And so we'll plus equal that. That'll be 12. And we're done with that line. We go up, and now we're at the for loop again. And what we're going to do is I is now 2. And so we already know the sum 1 is just going to be what is 2 at 2. And so matrix of 2, what is that? That is this index right here. And so what is the second index of this one right here? That will be the 9. Right there. So 9 plus equal to sum 1. That's going to be our 15. And same thing going on here. Length is still 3 minus 1. And I is going to be 2 of 2. There we go. And so what is that? That is 0 of 2. And what we're looking for there is matrix of 0. That's this index right here, the second, and that's going to be the 3. And so this guy is now 15. And so we increment I again. I is now 3. I used to be 2. I is now 3. And we go here. and we look at this this condition, 3 less than 3, that's not true, so we'll just exit this for loop and return math.absolute of sum 1 minus sum 2. That's 15 minus 15, that'll be 0. And you guys already know what math.abs does. It's just the absolute value of whatever math logic you put in there. And I guess one thing that you might be asking is, okay, I did like a -1 there. What's going on right there? How did I decide to do that? Well, that kind of comes with just running the problem and doing it. I was trying, at first I didn't have it there. It wasn't like, it's not like I did it on purpose at first, but as a matter of fact, when I first did this question, I had sum 1 correct. I knew that if I did this, it'll move down diagonally like this, and so I knew I needed to do matrix and I needed to go this way, but somehow I had it adding up this way. So instead of that, sum 1 was going down and my sum 2 was actually adding up, but it's the same diagonal, so it didn't make sense. And so I realized, okay, I do want to start here. And so I needed to have, using the I needed to somehow tap into the index of 2 of matrix. So instead of, that's what I needed my first index to be. And so if I had just done length minus I, that would have been 3 minus 0. And you already know that's an error because matrix of 3 is nothing. There is no third index to this matrix. And so if I tried doing that of I would get that error. Even though this would be 0, you're trying to tap into the index of 0 at an undefined. And so perhaps that's the error I had. Or at least that's the error you will definitely get if you try doing this. And so once you get that error, you know, okay, I'm trying to index into an undefined, and so something's wrong. I know that I'm going to have to be at my last index, and so how about length minus 1? And so if I do length minus 1, that would be 2 minus the I of I, and hey, look, I'm right there, and that does work. And even as I'm climbing up, and I'm climbing up because I is incrementing over here, it'll go correctly and stop at the right point of this diagonal. Cool, and so that's the only little nuance there. Other than that, I think that pretty much does it for this question. If you have any further questions, just be sure to ask in the comments. If you enjoyed this video, like, comment, and subscribe, and I'll catch you in the next one.